Welcome back, physics fans. This is lesson 4 in the first chapter. Even though it says chapter 2 here, it's in the first chapter of kinematics. It's called Constant Velocity, chapter 1. It's on time and frequency. It doesn't really fit anywhere else, so we'll put it here. Okay. Few things in our universe are at rest. Most are in constant motion, whether it be planets orbiting the sun, electrons orbiting the atom, birds orbiting other birds in the sky. Describe these motions mathematically using simple branch of physics known as kinematics is the first step to understanding them. Time is measured by clocks. Any regular repeated motion can be used as a clock. Early man marked the time of rising and setting of the sun. Grandfather clocks used to and fro motion of pendulums. Let's just take a quick peek. The to and fro motion of the pendulum. Back and forth. Okay. Modern cesium atomic clocks use regular repeated motions of inside cesium atoms, measuring the time accuracy to about a millionth of a second per year. Pretty good stuff. To describe any regular repeated motion, we need to use the quantities called period and frequency. Period and frequency. When an object makes repeated motions, one complete motion, back and forth, wherever it is called a cycle. And the time time required for one cycle is called the period. So T is the letter that we use for period, capital T. It's the time per cycle. And we get lazy and we usually just call it measurement in seconds, but it could be seconds per cycle. The seconds per one cycle. And that's the period. Okay? The number of cycles in 1 second is called the frequency. So we give that a little f, a script f actually, lowercase f, frequency, and that is cycles per second. And its unit is cycles per second, and we also give it and call that hertz. So we call that frequency. Let's just do a quick sample problem here. A clock completes 240 cycles in 60 seconds. What is its period? So the period is the time per cycle. So it's 60 seconds. So we put the time up top, and we put 240 cycles down below. And the seconds per cycle is 0.25 seconds. Okay, 60 divided by 240 is 0.25. And then it says, what is the frequency? The frequency is the cycles per second, so we put the 240 cycles divided by the 60 seconds, because that's its definition. You memorize that, and that'll be cycles per second, or also hertz. And if you notice, they are reciprocals of one another. Okay, so cycles per second, and the other one is seconds per cycle. So the reciprocals meaning 1 over each other. So once you have one, you can get the other by, on the calculator, doing 1 over it. And we can just verify that. If we have the frequency here, 1 over the frequency, which is 1 over 4, is the period, 0.25. So the period is 1 over the frequency. Okay, so we use that. We use that formula. Which formula? This one. Okay, or the same as this, if you have backwards. Okay, so let's take a look at number 1. A recording timer makes 540 dots in 4 seconds. What is its period? The period is the time per cycle. and the time here is 4 seconds, and it will make 540 dots. That's the cycle is making a dot. Let's pull up our calculator here, and we go 4 seconds divided by 540 dots, and we get 0.007407. Okay, a repeating number there. And this units will be seconds, because the period is, for it to do one cycle, is that much time. Okay, number 2. Let's take a look at number 2. A recording timer has a period of 0.025 seconds. How many dots does it make in 0.8 seconds? Very tough question. At least right away, it throws you into the hot water. Here we go. I have typed it up over here. If the period is 0.025 seconds, then the frequency is 1 over that. 1 over the period is 40 hertz. And that's 40 dots per second. 40 dots per second. And that is a conversion factor. That's the conversion brackets, right? We've talked about conversion brackets before. I'm making a little bit of emphasis on that today, that once we have the dots per second, it's dots per second. It's kind of a conversion bracket. So if we want the number of dots, new dots, we take the time that's used and this conversion bracket. So the time is 0.8 seconds. Time is 0.8 seconds. This conversion is 40 dots per second. And you'll notice now why I'm doing that is because you can see the units just cancel and we end up with dots. 0.8 seconds times this conversion factor will give us 32 dots. And that's how many dots are created. Yay, got it right. So try the rest. This is good physics here, good period and frequency. Ones that are really good to pay attention to. Number 5, common question. Number 6, common. And number 9, I've seen that even on the final exam, something exactly like that. Okay, so this is a sample. Now 10 and 11, I've run off and gotten a little bit more difficult and had a little bit of fun and stuff like that. But those are good questions. Try them. They will not be on a test. They will not be, but they're good. They're good. Okay, and remember, we have to get, you'll need the circumference. Circumference of a circle is either pi d, the diameter, or 2 pi r. Is the circumference of the circle, because that's a car tire, which is round. Anyways, we'll leave that alone. Thank you for watching. Hope you enjoyed it. And I'll just, in a few seconds, I'll put up some answers here. And there's the answers. How fast is the car moving? 38.33. And what is the instantaneous velocity of the tip of the blade? Is 120.95 meters per second tangentially. That's the direction. So at one point, let's just, this blade is going around. At one point, how fast is it going? Okay, it's going that fast of 120.95 meters per second. And the direction is tangentially, so it's asking for a velocity. We need a velocity that's tangential. It's going this direction. It's going at a tangent to it. At any particular point, that's the direction. It's not going radially away or radially towards. It's going tangential. Anyhow, good luck. Have fun.